my Lab 1 presentation on constant velocity. The purpose of this lab is to observe and model Newton's first and second laws of motion. To do this, we had to film an object moving at a constant velocity. Then we used this data to get a velocity value to use in the GlowScript code for our model. In GlowScript, we tried to create an accurate model for our observed object. By tracking the position and time, we were able to create a graph to compare our model and observation data. Newton's first law states that an object at rest will remain at rest, and an object in motion with a constant velocity will remain in motion at that constant velocity unless acted on by an unbalanced force. And Newton's second law tells us that final velocity equals initial velocity plus the net force divided by mass times delta t. This relates to our lab because we are predicting the motion of an object with constant velocity, and when velocity is constant, F net should equal 0. To use Tracker, I set the x-axis along the ball's path. Then I plotted a point in the center of the ball once per frame, and it created a graph and a table to show the data. With GlowScript, I used the starter code and had to change the values of several variables, as well as redefining some. I used the frame rate of my video to get the delta t value. Then I ensured the Fnet was equal to 0 to ensure constant velocity, and redefined the velocity and position formulas. The graphs on the left are what the code results in, along with the model of a ball moving in a straight line. Here is the first graph I created using the data. The model data moves at a slower rate, and it has a constant velocity, whereas my observation data is increasing faster, and the velocity seems to be increasing. There's an obvious difference, and for my GlowScript model, I used the time 0.2 and 0.17 seconds to calculate the velocity to put in my code. This gave me an average velocity of 0.74 meters per second. I should have started Tracker at 0.5 seconds. The graph shows that this is where the acceleration seems to stop and the constant velocity seems to begin. It's not completely constant because of gravity, friction, air resistance, and probably other forces that are acting on the object. I duplicated my GlowScript code and used an updated velocity from times 0.57 and 0.53 seconds. There is still much error in my data, and the graph is still off. The times I chose to calculate my velocity shouldn't matter because if Fnet really did equal 0, the velocity would be constant. This indicates that my object is not moving at a constant velocity, and this error is most likely due to the strong winds that were blowing the day I recorded. What if I had flipped the axes? Then I would have the same data, only the position and velocity would have moved in the negative direction. What does this mean? The observed data I collected shows that my object didn't have constant velocity. It's impossible to calculate every individual force involved, although you can calculate the net force.